So let's see how large distances we can measure. For that purpose, there is one method named parallax method. Okay, let me tell you meaning of this word first, parallax. For that purpose, you need to do one experiment. You have to put one finger in between your eyes and the object in front of your wall, and first of all you need to close your one eye and you need to see that object by second eye, and in second step you need to close your second eye and you need to see object by first eye. Then you must observe that there is change in the position of the object. So that change in the position of the object is nothing but parallax. Okay, so what happens, let's figure out what exactly we have did. Here is the object on opposite wall of you, and here are your two eyes. This is I1 and this is I2. Let's draw the lines. Okay, so this is the angle. This angle is called as parallax angle. Parallax angle. As our eyes make angle with the object, that angle is parallax angle. Suppose distance between two eyes is small d, distance between eyes and that object is d. Then we can find out distance between eyes and object. How we can find out? Let's put one formula. Angle is equal to arc length upon radius. As this is a small distance and we can treat as a part of circle of which radius is this distance. Okay, and according to this, d is equal to d upon theta. So in this manner we can find out this distance. We can apply same concept with same concept for measurement of distance of stars and planets from the earth. So let's say how we measure distance of planet from the earth. Let's consider this is earth, and here there are 2 points on earth. Suppose these points are A and B. This is earth, and here is the planet, suppose Jupiter. Okay, now what we have to do, we have to measure the distance between Jupiter and earth. Here is the angle theta, which is called as parallax angle, and this is the supposed distance between 2 points on earth, which we can measure easily. And here is the Jupiter. This angle is parallax angle, and suppose this this point is J, this is D, the distance between earth and Jupiter. That distance we have to measure. We know this distance and we know the angle. Now how to apply this method? Same formula you have to use, but over here we have to understand one thing, as this distance is very small than the distance between earth and Jupiter. The distance between earth and Jupiter in millions of kilometers and this in thousands of kilometers. So of course this d is much higher than this d. So this d we can take as arc of the big circle, of which this d is the radius. So that's why we can apply one concept, theta is equal to d upon d, and therefore this distance between Jupiter and earth is equal to d upon theta. So simply we have to apply this formula and we have to find the distance between two planets. So that's it. That is called as use of parallax method for measurement of distance between earth and planet. This parallax method also can be used to measure the distance between earth and stars, but keep in mind stars are very far distance from the earth. Nearest star we know is Alpha Centauri, which is, this is suppose earth, and distance between star Alpha Centauri and earth is 4.37 light years. What exactly meaning of distance 4.37 light years? I will tell you. Alpha Centauri is the nearby star to Earth after Sun. Sun is over here, suppose, and Alpha Centauri is at that much distance, which is Sun and Earth distance is only 15 crore kilometer, and this distance is 4.37 light years. As you need to understand what is 1 light year. 1 light year. How much is the distance covered by light in 1 second? 3 lakh kilometer is the distance covered by light in 1 second. Now how much distance that light will cover in 1 minute? 3 lakh into 60. Again, if we do into 60, then it will be the distance covered by light in 1 hour. Then again we can multiply it by 24, that will be the distance covered by light in 1 day. Again, if we multiply it by 30, then it will come the distance covered by light year in 1 month, and if we multiply it by 12, then this will give us the distance covered by light in 1 year. So it will be in kilometers. You can just imagine how big digit it will be, and that is what the distance covered by light in 1 complete year. Alright, so 1 light year is that big digit. So you can just imagine how big distance between Earth and the nearby star to us after Sun. So we can't measure the distance between Earth and star by using our conventional parallax method. For that purpose, we have to do one thing. Suppose this is the Sun and this is the Earth. Suppose this is Alpha Centauri star, Alpha Centauri. This distance we have to measure. We can take one point on Earth over here, and when Earth goes to another side of Sun after 6 months, this is E2 position and this is E1 position, and then we can make one angle with the star, and this angle is the theta. This distance we can take as small d, this distance we can take as capital D, and again as d is very smaller than the d, we can apply formula theta is equal to d upon d, and d is equal to the distance between Earth and star is equal to d upon theta. So by this way we can measure this huge distance between Earth and star. The nearby star is Alpha Centauri, as I told you, which is only 4.37 light years away from us, and if we look at the other stars, they are far away than that also. This method is useful to measure the distance of stars from the Earth. I hope you found it useful. Still, if you have any doubts, you can ask me in comment section below. I will try to answer those. And if you found this lecture series useful, please don't forget to subscribe our channel. I will see you in the next lecture.